Hey guys! So today you and I are going to talk about clean and maintainable code. So let's get into it. So the question in question was, hi Frederick, how can software developers write clean and maintainable code? Well, I will tell you what I at the very least try to follow as much as possible, and then it's of course up to you to tell me whether or not my code is clean and maintainable. Hopefully I will have something for you that gives you at least a nudge in the right direction, because as you can probably imagine, writing clean and maintainable code it's a little bit subjective, because I mean, if we all knew exactly how to do that under all circumstances, hey, why then we wouldn't have all these various types of bugs and issues and things like that that exists in the wild. But so the first principle that I try to follow is that first and foremost, try to the best of your abilities to follow the basics. And this is actually something that I see it in every single, almost all the time. Every single time I go to a new team or I come to a company or things like that. And at this point, guys, it's you can go and check my CV and so forth if you want to. Uh, it actually has been my role for the past few years to address these sorts of, issues with quality and maintainability and clean code and things like that. And I always find almost the same thing. People skip the basics. And when I mean the basic, I mean that when I come to a team, they are more or less not really writing unit tests, just as an example. And what I always tell people is that if you can't even do the basics, why would you be able to handle more complicated concepts? And so I try to approach it that way. The first and foremost thing I try to tell people is that if you want to make sure that your code is clean and maintainable, you have to know yourself well enough to know how to make yourself follow basic practices. So what I usually do is that I create a CI pipeline. This is you can take this as a basically, well, it's the closest thing I can give you to a silver bullet, because it is something I do for myself when I do my own personal projects, and it's something I do for every single team I've ever worked with, at least in the past 4 years, 5 years ish, something like that. So I start by creating a CI pipeline. And the first thing I do is to put a test coverage threshold into the CI pipeline. In other words, you have to have a certain percentage of coverage in order to pass the pipeline, otherwise it's going to break and you can't merge. And some people tell me that, yeah, but that doesn't mean that you write clean and maintainable code, it just means that you have test coverage. Correct. That is correct. But I argue that this is as important as having a linter or a type checker or something like, depending on language now, of course, but let's just say a linter for simplicity's sake. If you are using a linter to capture small issues with formatting and things like that, you are by default finding more issues, and you're able to correct more mistakes than if you did not. Same thing goes for test coverage. If you are not writing unit test, or you have a really low coverage or something like that, this will at the very least remind you to do that. Now, there are tons of other issues that come with that, because then we come into quality and, are you writing good test, bad test, all these sorts of things. But I always argue for the same thing. At the very least, you will check if you are going up or down. And then what I usually do is that after a week or two, depending on how fast we deliver things, I create I bump the number. So basically, you're continuously trying to push the number as high as possible, so it doesn't just go up and then drop down in the next iteration or whatever you're doing, right? So that's the first and foremost thing. And then I make sure that my test pipeline is designed in order to figure out if there are any issues. And that means that the pipeline is checking linting, tests, and it's doing type checking if I have a typed language. It's also trying, if let's say that you're running things in a container or something like that, then I might have some integration test or something like that. Like I build a Docker container, for example, and I start it, and then I run some basic tests against my interface and things like that. If you're using a UI or something like that, you might want to use Cypress or so forth in order to actually validate the application. So you do like there's a very good quote that I really like, which is that the master branch or main branch should try to defend itself against bad code. It should be designed to defend itself, and that is how I design my pipeline, because that way I know that I have created a self-imposed check, because I know that I am a human, and I know that some days I'm tired, I haven't had my sugar or my coffee or whatever I might need, so I'm not going to be up, be on my best, like on my game, right? I'm going to be producing things that may not be so great. And so I have to make sure that I know myself well enough to put checks and balances in place that will make sure that I always, as I like to say, the only difference between when I'm on my best day and my worst day should be how fast I solve the problem. Ideally, I mean, it's not possible to design a pipeline that is so perfect, but I mean, that would be great. But I try to do that. That's number one. Get your basics in place. Because once that happens, the next thing happens, which is that now, in order for you to actually make sure that your code is testable and that it works and all of that sort of stuff, you have to learn how to write clean, maintainable code. And it's actually very funny, because most of the time, a simple thing as just making sure that everybody's writing unit tests forces, in many cases for me and my teams that I work with, like, what they basically find immediately is that, oh no, I don't really know how to write good tests, or oh no, like all this code is really difficult to test. And I go, yeah, so now you're going to have to refactor, because the code, as I said, like, you have written shitty code that cannot be tested or can't be validated in any way. And so now you have to think about your architecture and your structure and so forth. So it becomes the first step on a journey of reshaping the code base into something nice and clean and easy to use. And that brings us to the second thing that I always do, which is that I try to write, as I call it, disposable code. Some people call it modularized code, loose coupling, and so forth and so forth. The reason I call it disposable code is because when I design like any code, it doesn't matter if it's a class or a UI component or anything like that, I try to think about things in terms of modules. In other words, if you think about it as a file or like as a folder in your repo, you create a folder that is named, let's say, something like the login page, for example. All right. So in the login page, there's a bunch of UI components. Those have their own modules. So like you might have your input field, you might have your username field, password field, your submit button and stuff like that. In the same way we think about encapsulation within a class, for example, you think the same way about your folders, your source structure. Because a lot of projects, what they do is that they create one gigantic monolith system where you basically have a source folder, and then you have like every single thing in different, like all across the place, and that becomes a mess very quickly. But if you structure it in the same idea as with a module, which is the same way, for example, when you download packages from some package repo, depending on where you like what type of language you're using, that is how it should work, in my opinion, because that is what I call disposable code. The reason why I argue that is because if you pull in an external code package and you don't want that anymore, removing it should be as easy as just removing like the code that you are consuming and then deleting the package, and then you're done. It's very easy for you to opt out of that thing or undo if that makes sense to you. The reason why I argue for this, and I go as far as to say that the default for every project when it's starting fresh, or like even up to the really, really large scale, should be a modularized monolith, as I like to call them, or you can call it a monorepo as well if you would like to. It doesn't really, like, it really comes down to that, just that observation. Understand that every concept, like if it's is for us who do domain-driven design and things like that, every entity within your system has its own folder, and all it does is that it exposes the code that is necessary for modules outside of itself. That's what it does. Everything else is found within that folder. So if you were to, let's say, for some reason not want your product entity within your system, well, then you would just delete that folder. and then everything will be gone. I mean, you might have some compilation issues or like dependencies that are actually using this module in some fashion in other places of the code, but you would be very sure that everything related to this thing would be gone. The reason why I argue for this is because that is very easy to scale, because as I said, like you centralize all the code that is necessary for a given module into its own folder, and you can have subfolders and stuff like that. It's the same way. It's the same principle as as encapsulation within object-oriented programming. It's just that you do it with file systems, and then that module can then become a microservice if you would like it to be, and all the tests and everything like that can be focused onto that specific module. Ownership becomes fairly easy because now you can own a folder within the structure. And my favorite one of all of this is that if you do this, then if you're doing a backend thing or so forth and so forth, like the only thing your backend needs to the server needs to know about this module is how to instantiate the class, for example, because you're usually just exposed in a controller with some endpoints and things like that, and then you can instantiate that and put it into like your entry file, which is where the server starts up or something like that. UI components works exactly the same way. When you work with a UI component and the top module is, as I said, like say a login form or something like that, then you literally only need to do the same thing you do with all your npm packages. It's just a component that you import into the login page, for example, and you just put it in place. It would be the exact same thing as if you were to download like a carousel or like some pre-made component. You treat your file, you treat your own source code in the same way you treat npm packages or any type of external code. So what I want you to take away from this is that the way that I try to tell people to write clean and maintainable code is, number one, follow your basics. Make sure that you are creating a pipeline that makes sure that you write your unit tests, you do all these sort of cleanliness things, because it is so easy, guys. I promise you it is. It is a little bit like cleaning your house or going to the gym or something like that. It's not always you're going to be feeling like doing it and stuff like that, and that's why you have to account for, don't think about how you feel right now when you might be really hungry and really into making sure that everything is perfect. Think about how you're going to think when you're on your worst day, and prepare for that. Put some checks and balances in place so that you can always assure yourself that even on your worst day, you're still going to remember to write your tests, for example. And don't forget, you can always cheat and have cheat days, as with losing weight. You can cheat and just twiddle the numbers a little bit. It's more about you. It's more about making sure that you have these balances in place so that you continuously remind yourself to do the things that you care about. And then practice writing your tests and understanding what types of tests that you should be writing and things like that, because I promise you guys, it's difficult to learn how to write tests well. A lot of software developers don't take the time to do it, but it is really important. I promise you it's going to also affect the way you structure your code. And then the second thing is modularize your code, all the things. Don't create like one gigantic monolith. Try to think about your monolith as small sub-modules. It's just a repository with some, if it's a backend system, for example, it's just like a start file that loads up a web server of some sort, and then it loads in a bunch of controllers, and all those controllers are just coming from their various folders in your source folder. And all of those, they are isolated from each other, like they are just modules that represent different entities within your system. You can of course have shared modules and stuff like that, but it's the same thing as if you were to just have no files in your own folder, just one single web framework that just loads in a bunch of external packages that you downloaded, and they just expose the controllers, for example, that you need in the other end, like within your server, right? It's the exact same thing for backend and frontend here. Think about your own source code as if it was an npm package or a maven package or a NuGet package, or call it whatever you want, right? And structure your code accordingly, because what happens then is that you isolate problems into one part of the code instead of spreading it across the whole thing, and it becomes very flexible for you. You can lift any folder out and put it into a separate repo or create a microservice from it, or so forth and so forth. That way of structuring things makes very nice clean cuts between the different areas of your code, which means that you can really laser focus on some modules versus other modules. And it usually becomes easier for people to reason about as well, because instead of having to learn the entire repository and everything in the entire system, which might be really, really big, they can focus on individual pieces of it. And that I always found to help a lot. Have a great day.